We have seen that the unique Mobius transformation that transforms three distinct points Z1, Z2 and Z3 in the Z plane onto three distinct points W1, W2 and W3 respectively in the W plane is given by W minus W1, W2 minus W3, W minus W3 and W2 minus W1 is equal to Z minus Z1, Z2 minus Z3, Z minus Z3 and Z2 minus Z1. Okay, now so this is in the Z plane to the W plane. Now if one of the points is say infinity, point at infinity, say Z1 is infinity, then what would be the corresponding transformation? Actually this can be extended to the points at infinity also. So if say Z1 is say at point at infinity, okay, so then because we know that this Mobius transformation is a continuous mapping from the extended Z plane to extended W plane, so we need to show only that you put your Z1 here in this transformation, then set Z1, so this is say 1, Z1 equal to 1 over Z1, okay, 1 over Z1 in 1, and then your take take limit as Z1 goes to 0. Okay, so that is on the right hand side we have what? Your right side will become limit Z1 tending to 0 of Z minus Z1, but in this case your Z1 is infinity, so we put Z1 is equal to 1 over Z1, okay, and Z2 minus Z3 and Z minus Z3 and Z2 minus 1 over Z1. Okay, so we take this limit, and if you simplify, then you will find that this is Z1 Z1 minus 1, Z2 minus Z3, Z minus Z3 and Z2 Z1 minus 1. So if you take limit as Z1 tending to 0, this is minus 1, and here also it is minus 1, so that is cancelled out. So what is left out? So this is nothing but Z2 minus Z3 and Z minus Z3. So thus your transformation, the Mobius transformation becomes, so what is the Mobius transformation? So this is W2 minus W3, W minus W3, W2 minus W1, and that is equal to, on the right hand side we will have Z2 minus Z3 and Z minus Z3. Okay, so this is, we formally got that the Mobius transformation that transforms the point at infinity Z2 and Z3 to W1, W2, W3 is given by this. And if you compare this with the distinct points, that this one, then you see that it is just informally you can cancel out this. If Z1 is infinity, then this and this is cancelled out, and what is left out? Z2 minus Z3 and Z minus Z3 here. Okay, so therefore that is the usual informal procedure. If one of the points is at point at infinity, just you cancel that term. Okay, so for example, suppose your W2 is infinity, right? W2 is infinity, then what will be the corresponding transformation, Mobius transformation? It will be W minus W1, because W2 is infinity, so this term will not be there. So what will be there? In W2 is infinity, so it is W minus W3. On the left hand side we will only have this if your W2 is point at infinity. So formally we can take what? Your W2, the term having W2 is cancelled out. Okay, and on the right hand side, if say all points are not at point at infinity, so this is nothing but Z minus Z1 and Z minus Z3 and Z2 minus Z1. Okay, so that is the procedure. And if in this case also one of the points is at infinity, then you can cancel that term. For example, suppose your Z3 is infinity, so you cancel this term and this term, so that will be the corresponding transformation. Okay, so the point at infinity is also been considered when the three distinct points are mapped to three distinct points. Okay, so we can find if the point is a point, if the point of infinity is not considered, then this is the form, and if point at infinity is considered, then one of those terms will be cancelled out, and that will be the Mobius transformation. Okay, so in the next video I will give some examples of both the kinds. Okay, thank you.